This is the first of probably 2 videos looking at probability trees. This first one deals with unconditional probability. And so for this example, I want us to consider the following situation. Each morning, Jack chooses his breakfast cereal and juice at random from these options. His cereal might be oat flakes or Alpen. His juice might be apple or orange juice. The probability that he chooses oat flakes is given as 0.3. The probability that he chooses apple juice is given as 0.6. Notice that it doesn't matter which cereal he chooses. It doesn't affect the probability of what happens with the juice. If he picks oat flakes, that does not change what he will or won't do in terms of apple or orange juice. They're completely unconnected. And that's why this is unconditional probability. The juice doesn't depend upon the cereal. Now the question we're going to look at is, what is the probability that tomorrow morning he chooses items beginning with the same letter? Now in terms of setting this out as understandably as possible, what we do is we set up what's called a probability tree. It has 2 branches to begin with, and these 2 branches consider what happens with the cereal. Perhaps he picks oat flakes, perhaps he picks Alpen. And we can write some probabilities on. The probability that he picks oat flakes is 0.3. We're not told about the Alpen, but that's because we can work it out ourselves now. We know that he definitely picks one of these. So it's certain that he picks one of these. Certainty in probability equates to 1. So these 2 probabilities together have to add up to 1. So the probability of him picking Alpen must be 0.7. Okay, so he's now picked one of his cereals. He then goes on to pick some juice. If he has chosen some oat flakes, then perhaps he chooses some apple or orange juice. Equally, if he's picked some Alpen, again, perhaps he picks some apple or some orange juice. We're not saying that he does this and this, because from the left, the timeline starts here, and once he's chosen a cereal, perhaps Alpen, then he's on this line towards the end. He can't go along that line anymore. So although it appears that the juice appears twice, as far as him picking some juice is concerned, it's only either from the Alpen or from the oat flakes. Now, the probability he chooses apple is 0.6, so I can fill those in. And for the same reason as described previously, the orange juice must therefore be 0.4. Now, what's the probability that tomorrow morning he chooses items beginning with the same letter? Well, that happens if he chooses oat flakes followed by orange juice, or if he chooses Alpen followed by apple juice. These are the 2 branches that we're interested in. Now, there is some key terminology here, some key words that you need to know. If we find ourselves saying the probability of something and then something else, that word "and" tells us that we're going to multiply. If instead we talk about the probability of something or something else, that word "or" tells us that we should add the probabilities. This is worth learning. So the probability of him choosing oat flakes and orange juice is 0.3 times 0.4. So that's 0.12. The probability of him choosing Alpen and apple is 0.7 times 0.6. That is 0.42. Notice in both those cases, as we moved along the branch, we said oat flakes and orange. That's why we multiplied. Alpen and apple. Again, that's why we multiplied. But now we say, okay, we're interested in him choosing this or this. And that forces us to add these two branches together. And so we're looking at a final answer of 0.54. The probability of him picking two items, both beginning with the same letter, for breakfast is 0.54. And that's how you deal with an unconditional probability question.